Hi guys, and welcome to a new section where we are going to focus on Python for the web and webbing with the power of Python. So remember to download all the exercise files if you need them, if you don't want to type everything in the IDE. And also I will put the download link, the links to the examples that I'm showing from the web. We will be getting some data from the web, from APIs. So let's get started. So okay, Python on the web. So up to this point, we've been using Python locally to investigate and parse data on our local machine. But what about when you want to use Python for remote data manipulation or across the wire? Python is a very powerful language, and it's not just for doing system administration tasks or file system tasks locally. You can use Python across networks to handle tasks using REST and XML/RPC. So in this section we'll look into both of these, but the focus is on the most popular method of using Python remotely, HTTP, using REST. And also in this section we are going to use some of the more popular web technologies with Python, including HTTP and REST, to create a web app that links to a database. We'll use technologies such as Flask and SQLite to complete the web app. And finally, we'll create an application programming interface, an API, and learn to parse and manipulate data in the web app. And REST stands for Representational State Transfer. It's a fancy name for the technology and architecture style of a certain web service. This service doesn't rely on the implementation of components or protocol syntax. Instead, it worries about how to interact with data, like sending it back and forth within the constraints placed upon it. I'll explain RESTful architecture when we are going to build an API with Flask. For now, just know that REST is a thing that makes up the architecture of a web service. And also note on the front-end development, and because it's beyond the scope of this course to teach the fundamentals of front-end web development, we've provided some files you need to have for a nice interface as a download in the zip file. In this course we will be focusing on the middle layer of Python and how to hook up the front end to the database and web server. We can only lightly touch on the JavaScript that is provided. It is recommended that you familiarize yourself with modern front-end technologies should you be focusing your Python development on the web. So let's move on to Python on the web. As you may know, the web is made up of a few technologies, not just one. And this this foil shows a high-level overview of the structure of a modern web app. You have the client side where the browser resides, and that's technologies using HTML, CSS, JavaScript. And then you have the server side where you have the API and the data. So note the two sides of a web app, the client side and the server side. And server side data is served via web servers such as Apache or Nginx. And as you can see, the front end of a web app consists of a browser that handles the HTML, CSS, and JavaScript. The middle layer in this case is Python, but in general this is usually some scripting language such as Ruby, Perl, PHP, or JavaScript. The back end will house your data. in our case SQLite, and web server or HTTP daemon, commonly Jinx or Apache. Although it's beyond the scope of this course to explain the fundamentals of the backend and front end, you will learn how to set up a very simple server. And one note is that if you should need to make this server public, it is highly recommended that you fully understand the fundamentals of any technology with which you are unfamiliar. So read the docs and documentation and know what you're getting into, and learn how to securely set up a public-facing web server before doing so. So let's move on and start explaining how each of these pieces work together. So when you have parts of a web application, you can serve data across networks in a few ways. Python is a language that can handle almost all of those ways. We briefly touch on the most common uses of Python as a server-side language, and then we use the modern and most common way of using Python on the web, building a web application. So you can see the basic structure of any network request on the first line of this flow. Request is made, and then server receives a request, and then server returns data to requester. So questions to ask is, what happens between server receives requests and server returns data to requester? So that's where Python lives. Because browsers can't ship with every interpreter ever created, and we certainly don't want them to come with compilers, we needed to find a way to bridge static pages and dynamic data so that we could have interactive dynamic web pages. We know that we have a web server that is serving up files that make up our web app, but how does the server know what files we're using? Or how can the server tell that the app is written in Python and not, say, Ruby? So that's where WSGI comes in. WSGI, or Web Server Gateway Interface, is how your web server, like Apache, knows about and can run Python files. And again, it is beyond the scope of this course to delve into the intricacies of WSGI. Just know that modern web servers support it, and if you want to run Python on a server, that server needs to have WSGI available. If you are interested in a deeper understanding of server operations and what is known as DevOps, it is recommended that you reach the more lower level technologies such as WSGI. For our purposes, however, we'll be using a framework that has already taken care of that piece of server architecture for us and uses WSGI. We will see this term referenced throughout when discussing Python on the web, so hopefully you'll remember it and understand what part it plays in the grand scheme of things. And the next point on the presentation is the client-server relationship. So what is a client? In web development, a client usually refers to a web browser which sends out requests to your web server for files. However, you will see other uses of the term client to mean another server that is requesting data from a second server. For the purposes of this lesson, a client is basically a browser. In other words, the part of the web app that wants to display the data that the app is returning. This is also the part of the web app that the user will be interacting with. If you've ever heard the term client-side JavaScript and never really understood it, this should clear up that confusion. Client-side JavaScript is JavaScript that is only on the client side and performs actions directly on the client, like a web server, and not on the server. Directly in the client, a web browser, sorry. This includes, for example, changing colors or styles on a web page when certain events are fired. For example, a button click changes the color of a background. These functions never actually talk to a server and can be used locally if needed without an internet connection. So what is server-side JavaScript? And it's JavaScript that is executed on the server, usually by an event from the client side, such as a GET request or client-side JavaScript. We won't be dealing with any server-side JavaScript in this course because we're using Python, which is our server-side language of choice. This is where our logic will live. And this is the part of the app that takes the actions from the client and makes the magic happen. And the next point on the presentation is middleware and MVC. Middleware is a fairly new term in web development. It refers to the part of the technology stack that will take in data from the front end, the client, manipulate it, pass it on into or out of the database or other service that may be running, and then send it back to the front end. Basically, the logic of your system or your app should live in your middle layer, your data should live in your data layer, and your styles should live in the front end. It is never ideal to have your front end, the JavaScript, doing much data logic, which can be better handled in your middle layer. So all of these pieces actually have a nice name. It is called Model View Controller, or MVC for short. Most modern frameworks use some sort of MVC architecture. The benefit of MVC is that your client doesn't have to deal with the logic of your app, and your logic doesn't have to deal with your data models. You can set excuse me, you can set your data models and forget it, sort of. Say you're working on a large project and you have web designers writing your HTML and CSS and some of the JavaScript that makes your web app look nice. Then you have very smart mathematicians working on your data layer because you need precise numbers to be calculated from data inputted from for a nice looking client. What happens if you have your logic code in your client-side files? Let's say you put your calculations in the templates that the web designers were working on. Furthermore, let's say that your web designers wanted to manipulate something and they thought your calculation was the problem. So that's not very ideal. MVC somewhat solves this problem by separating your data layer, the data model that is storing your precise calculations, from the controllers you're writing to do your precise calculations, with the view that your web designers are working on to make a nice looking app. So what does all this mean in Python world? We're going to come across the term MVC, and you should understand the overview of the architecture. We use a framework in this lesson and section that utilizes a sort of MVC architecture. So you should now have a better understanding of why we made most of the decisions we made moving forward. And then we have the HTTP methods and headers. HTTP stands for Hypertext Transfer Protocol. This is the protocol that is used to pass data around on the web, usually via a web browser. When a client makes a request, it uses this HTTP protocol. So this might look familiar to anyone who's done any web programming with hypertext markup language or HTML. HTTP is made to pass HTML. HTTP methods are the verbs of the web. The two most basic methods are get and post. These do what you might expect. When you send the web server a GET request, you are requesting requesting to get data from the server. This request or get is used every time you load a web page into your browser. So when you go to twitter.com, your browser is sending a GET request to the Twitter servers and asking for information. So what about when you type out a tweet and hit the tweet button? When you are sending the data to the server, you are using a post method call. This indicates to the server that you are going to attempt to post data to the server. So we will lightly touch on some other methods calls as we go through the process of building our app. So if you plan to use Python for web development, it is highly recommended that you familiarize yourself with all the HTTP methods available. So let's just try out one. Let's see what HTTP does. So how does the web server know what method is being sent? It does via the HTTP headers. So if you go to the, for example, a website, let's go to python.org and you use a tool called developer tools. This is Chrome developer tool. So if you just get it from the menu and under more tools, if you haven't added that, you can add that from Chrome Store, I think. So let's just reload this page and let's find a JavaScript file. So let's just find one here, and you can see under the headers what kind of request method we are using. So as you can see from the screen, we are going to python.org, and in doing so we have sent a GET request to the server for a JavaScript file. The server excuse me, the server responded with a status code of 200 OK, which simply means that the file was available to be served and was served. Other HTTP status codes exist. The code 4is4 is the most widely known. It means not found, meaning the file was not found on the server, so it could not be served. And headers contain information for the server to know what you are requesting from the server. This helps the HTTP or web server to respond properly to requests that are made from the internet. Headers also contain metadata, such as what browser was being used to make the request. And also, as you can see from the screen, the request was made using Chrome. The Chrome browser. So if you're going to be developing for the web and you don't have a dedicated front-end team to check your API's implementation, you're going to have to do your own debugging. So it's helpful to know how your API will be accessed to be able to replicate that for testing and debugging purposes. To do this, you will be using the Chrome developer tools. So to find the Chrome developer, you can open your Chrome developer from the menu, which is here. Go to more tools and then developer tools. And just browse to a site like, for example, python.org and find a .js file. Click on it and you'll see a new window appear in the right pane with the preview tab highlighted, or the headers will be highlighted in this case. So you should now see the HTTP header that was sent to the server requesting the file, along with the response headers that the server returned. So feel free to click around to see what the server actually returned. You can click around with the response. So we'll work more with the response tab later on when we start debugging our own API. So DevTools will be one of the most used tools you'll work with if you are doing web development. Another tool that may come in handy while testing your API, if you don't want to test using a live page, is Simple REST Client. This is a free Chrome plugin that you can find in the Chrome App Store and install directly into Chrome. Of course, other REST clients are available, so feel free to find one that suits you. So now also let's talk about the next point, which is API, which we are going to work with. So what is an API? API stands for Application Programming Interface. An API is simply the approved way for others to interact with an outside application without actually having access to the database itself. Take Twitter, for example. How do the many Twitter clients out there get the Twitter data? Does Twitter just let anyone onto its systems? No, not really. Twitter uses an API to allow other developers to utilize its data. The modern use of an API is a RESTful API, meaning that you use URLs to talk to the remote application's API, and the remote application returns data depending on the data you sent to the specified URL. You can find many tutorials online that show you how to use certain libraries in Python to access an API and pull data. We will be going a step further than that. We will create our own API to serve data. We will then use that API to code up our client-side files to pull in the correct data. But first, we'll look at the data that most API returns, which is JSON. And JSON stands for JavaScript Object Notation. If you ever heard the term JSON, you probably thought it was some magical secret that only super smart computer scientists understood. Or you just thought it was some weird thing that web developers kept going on about. Either way, it's very fast, almost too easy to understand. JSON is simply key value pairs that are formatted to reassemble a JavaScript object. Like dicts in Python, JavaScript has a data structure that is very similar. They are called objects in JavaScript, and they look like this section here. So this is how a JavaScript object looks like. So this is simply an object with 3 keys: name, email, and job. Each key has a corresponding value. When we talk to most modern APIs, the format of the data that is sent and received is usually JSON. This means that we simply have to structure our data as key value pairs and wrap it in curly braces. Some APIs can have JSON sent to them along with them sending JSON back out. And some APIs simply provide JSON data. We'll look at a third-party API that sends data as JSON. We'll look at how to parse that data, how to read it, and how Python handles it. So for this exercise, we are going to use an example from the USD ACE API for farmers markets in a given area. And you can find plenty of other governmental APIs at www.data.gov. So for the documentation that we are going to use, you can find it under this link. I will put this link in the description of this lesson. So have a look at it and how we are going to find the URLs. And this is the URL we are going to use. This is for JavaScript, and you also have for explanations for C#, Visual Basics. So, but this is the URL that we are going to use in our example. So before we start exercise, just make sure that you have requests library installed. You can do that by pip install requests. If I also have pip installed, I have already installed it. So I'm going to use the Python console here in the PyCharm, but you can use the command line prompt or terminal if you want. So let's try to find some data from the USD ACE API for farmers markets in a given area. So import the requests library. So failures online it's good. I did some testing with changing some of the settings, so I think I messed up, but I'll use the Python interpreter. So I'll just use this from the command line because I know it works. Hi guys, I just had to make sure that I got PyCharm to get working with the request, because it's important that it works in your IDE. So I will show you how you can install that. You have to go to settings, and under your project go to Python interpreter, and you won't find requests installed in here, even though if you have installed it via pip. So just search for it and you will find it there, and then install package from package installer of PyCharm. So just wanted to show you guys how you can do that. So it should be working now. Yes, we have Houston, we are online. So then we are going to make a request to the USD ACE API. and as we have to save the object return from a request into a variable and then print that result. So we'll make a call to this, not this one. We have to make it equal to this. Excuse me, we have to, I am now, this is the link for a specific zip postal code, zip code. I'll put this link in the description as well. So and we put the link in here. So, and please play around by replacing the zip code with your own zip code if you are in the US to see a local farmers market in your area. And let's print out the result, and here we are calling requests.get function. Earlier we talked about HTTP request methods. This request is sending a GET request to the server to get back some data, a JSON object in this case. So what do we know about an HTTP response status code of 200? This simply means that the request was received and returned OK, meaning everything is OK. So now let's call the .json method on the object so that it is in a form that Python can understand. And we'll save the result of calling the .json method on the object that was returned and print the value. So this will give us a long string of results. So what we are seeing here is a list of the markets that is returned when you query that zip code. The data for this query lives on the USDA's server. However, because the USDA has provided an API, we can access this data without actually accessing the database itself. So what data type is being returned? It is a one item dict with the key results containing a list of dicts as its values. How do we know that? That's curly brackets are dicts and the square bracket is a list. And then we have the curly brackets again. So the first dict item is titled results and its data is a list. Remember that dicts are key value pairs. Remember lists are simply number indices with the 0th indexed. So how do we get the list out of the first dict? We have to reference the dict with its key. In this case, the key is the word results after the curly brackets. Excuse me. So to get the value of that key, let's call it like this. It's a little bit more readable. So lots of data here. I think I just have to use it like this. Much better. So I just had an S too much because this gives us the wrong representation. So this is much more readable. So we can see that a Unicode encoded list of farmers market for the area of Indianapolis with the zip code of 46201. So, or you can change the zip code if you change that data point. So how does this work? Excuse me. We just used an API from the USDA to search for farmers markets within a certain zip code based on the data housed in the USDA's databases. We got the result back from the server, and using the requests libraries.json method, we got that information out of the data the server sent back to us in the JSON format so that we could read it. We then noted the structure of the data so that we could get each individual listing and list them out via a for loop. So what if we wanted to get the name of the farmer's market and search for it via Google? Luckily, the USD has done the heavy lifting of finding each market via Google Maps by providing a link to the corresponding Google map for each market. So this search according to the USDA API docs, which is here. And I will provide, as I said, I will provide this link. And this link will return some market details provided we pass in a market ID, which we can get from the earlier inquiry. So included in the result is a link to Google Map. So let's try it out in the interpreter. So if we just copy this link once more without the zip code. Actually, we need to change this. Because we want to get the market detail. I'll explain in a bit. And then we need the Google link. Okay, we have some, of course, the URL is have a typo in the URL. I forgot a question mark. Not question mark, but forgot to put ID there. So it's getting the Google links of all the farmer markets. So let's say we wanted to understand what's happening here and want to decipher this, so we can try to print out each line to see what the code looks like as it is going through each line. Just see what I'm writing. Typos. So this is actually what is happening in the background. So it stopped there. So let's try to do that with try this with the developer tool. Reload this. So in the headers, so it's identical to the response we got back when you queried the URL in the Python interpreter. So let's see the preview. So we can see each result returned as a JSON object, and feel free to click around and inspect the data that the browser can see with the data we've been inspecting. So now the question is, how does that work? How does the request library do that? And that's for our next lesson, when we are going to talk about web programming with Python. Though we won't be making our own requests like library, we will look at the underlying logic and functionality that Python provides in order to make such a library. So this is it for this lesson. So I hope to see you, or of course I will see you in the next lesson. Okay, see you.